Let's take a quick look at how infrared light works. All light can be described as a wave traveling through space. The distance between peaks is called the wavelength, which determines its energy, or in the case of visible light, its color. The wavelength of visible light ranges from about 400 nanometers for purple light to 700 nanometers for red light. This is the light our eyes see and what most photographs capture. Infrared light begins at wavelengths longer than red light. From about 700 nanometers to 2400 nanometers is called near infrared. This is the light we will be capturing with our camera. Longer infrared wavelengths are associated with heat and will not show up in our photographs. So how do we see this invisible light? Well, our camera will record the infrared light hitting the sensor and digitally convert it to a visible color. By using a filter in front of the sensor to block visible light, we can exclusively record infrared light, or by using a filter that allows a little bit of visible light through to mix into the image. In this example image taken with a 590 nanometer filter, you can see the infrared light reflected by the plants shows up as blue, and the visible light in the sky comes through as yellow, and then we can manipulate those colors as we like. It is important to remember that all light we see, and our camera sees, is reflected by an object from a source light. Some objects will reflect infrared light more than others. The sun produces a lot of infrared light, so it works out perfect for natural light photography. Some artificial light may or may not produce infrared results. It depends on the source. For example, this LED is emitting some infrared light, although it's quite a bit dimmer than it looks in visible light.